Hello guys, today we'll talk about V-belts. V-belts, as we know, have many applications. They're used in electric motors to run blowers and compressors, home appliances like mixers or grinders, or industrial machine tools like lathe and drilling. For calculating various factors, we have a design procedure. So over here we have 10 steps, starting from selection of belt section, going on to the pulley diameter, center distance, and finally calculating the number of belts required and the maximum power capacity. Here we have a question. By solving this question, I'll try and explain to you all the 10 different steps, going on to each and every design procedure step by step. So reading the question, we see we need to design a V-belt drive with the following specifications. Power to be transmitted is 7.5 kilowatts. Speed of driving wheel is 1440 rpm. Diameter of driving wheel is 300 rpm. Speed of driven wheel is 400 rpm. Center distance 1000 mm. Service time is 16 hours per day. So the very first step is selection of belt section, which is given on page number 7.58. Under the table data on standard V-belt sections, we will be choosing belt type B. Any of the 5 belts can be chosen, but for this question, let us go with belt type B. So next step is selection of pulley diameter. Jumping on to page 7.54, we have a table saying recommended series of pulley diameters and tolerances. Now given in our question, the diameter of driving wheel is 300 mm. If we look in the recommended series of pulley diameters and tolerances, under the nominal diameter section, we do not find 300 mm as such given in the table. So we will be choosing 315 mm as our nominal diameter. This is small d. For calculating the capital D, we have a formula: capital D by small d is equal to small n by capital N. So we know the values of small n, capital N, and small d. Putting this, we will get the answer as 1134 mm. Now similarly, under the same table, 1134 is not given. So we will be choosing the very next number which is given, which is 1250 mm. Now we'll jump on to the third step, which is the selection of center distance, given on page 7.61. While looking at the question, we also see that the given center distance is 1000 mm, so we do not need to find the center distance once again by using this formula. It is already given to us as 1000 mm. Just above the center distance formula, we have a formula for calculating the nominal pitch length of the belt. As we see this formula, by putting in the values of C, which is the center distance, which is 1000, capital D is 1250, and small d is 315 mm, we get an answer 4676.85 mm. Now again we need to standardize this value. For standardizing, we'll go to page 7.59 or 7.60. On 7.60, under nominal inside length, the value next to 4676 is 4953. So this is the value we'll be choosing, but the cross-section type of belt was B, so we'll be choosing 4996, which becomes our nominal pitch length now. Coming to step 5, which is selection of load correction factor, again given on the same table but towards the right hand side. Following the same row from 4996, we find the correction factor for belt B is 1.18. So this becomes our value FC, that is 1.18. Step 6 is the correction factor for arc of contact, given on page 7.68. The formula which is given contains capital D, small d, and C. All of these three are known to us. Calculating this, we get the value as 123.9. Right under the formula, we have another table for correction factor for arc of contact, FD. Looking in this table, we see that 123 is given to us. So we'll be choosing 123 because 127 is very high. So correction factor for VV is 0.83. Now if in the question it is given about V flat, then only we'll be going into that column. Otherwise, V is what we'll be choosing. Step 7 is selection of service factor, which is F alpha. Now, under the table correction factor for industrial service, we have 4 different types of services: light duty, medium duty, heavy duty, and extra heavy duty. Until or unless it is given in the question, please do not choose heavy duty or extra heavy duty. Go only with light duty and medium duty service. Now our question states that the machine is on for 16 hours per day. So we'll be choosing the column which says over 16 hours in continuous service. For the type of driving unit, I am choosing AC motors and DC motor type. So our value of F alpha is coming to be 1.3. 1.4 could also be used if I choose the other application over here. Continuing on with the procedure, step 8 states that calculation of maximum power capacity given on page 7.62. Now we see that the belt cross section which we chose was type B. So the complete formula is given over here. In this formula, two of the things are unknown, which is S and DE. The formula to calculate S is pi d and divide by 60 into 1000. We divided the complete equation by 1000 because we needed to convert d, which was in mm, to meters. So the value of S comes out to be 23.75 meter per second. Calculation for DE as given on page 7.62 only is dP into FB. So dP is the smaller diameter, which is 315 mm, and FB can be calculated as capital D by small d, which comes out to be 3.96. Multiplying these two, we get the answer as 359.1. But right next to the formula, we have the maximum value of DE to be used in the formula as 175. So, ignoring 359.1, we'll be choosing DE as 175. Putting both the values of S and DE into the formula, we get power as 5.44 kilowatt. For determination of number of belts, we look onto page 7.70. The formula is given on the top of the page. We require 5 different values over here. P, which was given in the question, F alpha, which we calculated as 1.3, KW, which we just found out to be 5.44 kilowatt, FC and FD, both of which we found out. So the value for number of belts is coming out to be 1.82. Rounded up, we'll be needing 2 belts. Now the last step is calculating the actual center distance given on page number 7.61. The formula has 2 unknowns, A and B, which can be calculated by the formulas given over there. So the value of A comes out to be 634.42 and the value of B comes out to be 1,09,278.125. So finally, the value of C is 1175.90 mm. The original center distance given in the question was 1000 mm, but from the values which we took and the values which we assumed, the center distance comes out to be 117.90 mm. I would just like to make this one point clear that each one of you will be getting different values because the values which you will be choosing will be different.